Chapters 13 and 14, Final Review. Anita Bushnell, Erin Cooney, and Susie White.
Chapter 13, Comparing two population parameters. For a two-sample z-test, this test is used when two samples are given, when the standard deviation of the population is known, and it is used to infer about the difference of populations using the difference of samples. For a two-sample z-test, it is used when two samples are given, when standard deviation of the population is unknown. It is used to infer about the differences of populations using the difference of the samples as well. When comparing two means tests, it is used to compare the responses of two treatments or compare the characteristics of two populations. So you first state what kind of sample it is. So a two-sample either Z or T test for a population means at usually alpha equals 0.05 if it's not stated. Then you have your null hypothesis, which is mean 1 equals mean 2, and then the alternative hypothesis, which is mean 1 does not equal mean 2. And then you have to state what mean 1 and what mean 2 is, which is usually the true mean of sample 1, whereas the mean 2 equals true mean of sample 2. And then you need to see if the conditions are met. So it needs to be an SRS from each population. The distributions need to be normal, or N1 plus N2 is greater or equal to 30 for the t-test, or N1 plus N2 needs to be greater or equal to 15 for a z-test. And then samples are independent, or the population needs to be greater or equal to 10 times the sample, and then vice versa for the sample too. And then you state, you also have to write out the formulas, which are to the right hand. And then for the last step, if the p-value is less than the given alpha value, we reject the null hypothesis. If the p-value is more than the given alpha value, then we fail to reject the null hypothesis. And then make sure to put your answer in context in part 4. Also make sure to include the statement, test only valid if all conditions are met. For a two-sample z-test, this interval is used when two samples are given, when the standard deviation of the population is known, and it is used to infer about the difference of populations using the difference of samples. On the other hand, for a two-sample t interval, this test is used when two samples are given and when the standard deviation of the population is unknown, and it is used to also infer about the difference of populations using the difference of the samples. So for the two-sample t interval for population mean, the conditions are the SRS from each needs to be from each population. Distributions need to be normal, or N1 plus N2 is greater or equal to 30 for t-test, or for z-test it needs to be greater or equal to than 15. And then the samples need to be independent, or the population needs to be greater or equal to 10 times the sample for the sample 1 and sample 2. And then for the t-distribution, they need degrees of freedom for which the calculator output or the smallest sample size minus 1 is used. The t-distribution, and it's pretty complicated, so usually we just use the calculator.
So for comparing two proportions for a test, you would use this test if you were given two samples of proportions. And for the null hypothesis, you would just state that proportion 1 equals proportion 2. And for the alternative hypothesis, you would say that they are not equal to each other. And then you'd have to state out P1 and P2, and those are just the true proportions of each population. And then you'd have to state out your conditions. So both sets of data of the populations, of the proportions, must be from an SRS, and both sets of data need to be normal, or you can see all the equations that you can check are normal. They must be greater than or equal to 10. And then all the samples must also be independent, or the populations must be greater than or equal to 10 times the sample size for both samples. And then in order to find the z value, you would use this big equation on the right. And in order to find the p hat c, you would also use that equation to the very right. And since this is a z-test, you do not have to state your degrees of freedom. For part 4, if the p-value is less than the given alpha value, we reject the null hypothesis. And if the p-value is more than the given alpha value, then we fail to reject the null hypothesis. And make sure to put your answer in context. And also make sure to include the statement, the test is only valid if all conditions are met. For comparing two proportions for an interval, you would state the confidence interval that was given in the problem. So, for example, it would be a two proportion z interval for the difference in proportions at 95% confidence interval, say. And then you would have to state P1, P2, so those would just be the true proportions of the populations, either one or two. And then you have to state your conditions, which are both sets of data from an SRS, and then they need to be independent, or the population must be greater than or equal to 10 times the sample size of both samples, and then they would need to be normal, and for the interval, your n1 times p hat 1 or n1 times 1 minus p hat 1 or 2 must be greater than or equal to 5. And then you would use this equation below to find the interval. And then in part 4, you would write, we are blank percent confident, in this case 95% confident, that the true difference in proportion is between the interval you found. Also, if 0 is on the interval, we conclude that there is no difference in proportions. If 0 is not on the interval, then we can conclude that there is a difference in proportions, and make sure to state that the interval is only valid if all conditions are met.
So chapter 14 is the inference for distribution of categorical variables. The first test is a chi-squared test for goodness of fit, which is used to see if the observed sample distribution is significantly different in some way from the hypothesized population distribution. The name of the test would be like chi-squared test for goodness of fit at alpha equals 0.05. Your null hypothesis would be that the observed counts or proportions are equal to the expected counts or proportions, and the alternative hypothesis would be that at least one observed count or proportion is not equal to the expected counts or proportions. And your calculations will always be in terms of counts. So if you're given the proportions, make sure you convert them to counts. The conditions for all three chi-squared tests are the same, which is data from an SRS, all expected counts greater than or equal to 5. The degrees of freedom for this particular test is number of categories minus 1, and the formula is the same for all three tests, which is chi-squared equals the sum of the observed minus the expected squared divided by the expected, and a chi-squared distribution is right skewed, and you would always shade to the right. For part 4, you talk about your conclusion based on the p-value, and you would either determine that the observed counts or proportions are equal to the expected counts or not. Next, a chi-square test for homogeneity, which is used to determine if a single categorical variable has the same distribution in two or more distinct populations from two or more samples. The null hypothesis would be that the distributions of category 1 are the same in all populations of category 2, and the alternative hypothesis would be that the distributions of category 1 are not the same in all populations of category 2. For chi-square tests of homogeneity and independence, you'll typically see a two-way table. So to figure out if all the expected counts are greater than or equal to 5, as part of the conditions, you would use a matrix, and your degrees of freedom would be the rows minus 1 times the column minus 1. And for part 4 again, based on the p-value, you would determine if the distributions of category 1 are the same in all populations of category 2, or if they are not. And finally, a chi-square test of independence is used to determine if there's an association between the categorical variables. The null hypothesis would be that there is no association, whereas the alternative hypothesis would be that there is an association between the row and column variables. Formula is again the same, and degrees of freedom as well, row minus 1 times column minus 1. Conditions are again the same, and you would see the same two-way type table. Again, your conclusion would be very similar, and you would like to the others as in the way that it would be based off the p-value, and you would either determine if there is an association between the categorical variables or if there is not.
If you're confused about which test to use, here's a good reference. And yep, thanks for watching.